Hi everyone, welcome back to Epione Biotech. For this video, I'm going to be going over our inner gear and top dial gear mechanisms that make up our 360-degree movements. As you can see here, this is the inner gear mechanism, and later on in the video, I'll go over the top dial gear, both of which are very similar in nature to design. So to begin, I'll just go ahead and start off with the history tree. We'll look at the first sketch, conveniently labeled sketch 2. So this is the basis of our gear was just a simple circle. This circle right here was 1.2 inches in diameter, and we went ahead and extruded it 0.25 inches. You can go ahead and take a look at this boss extrude. Yeah, we went ahead, 0.25 inches forward. And that gave us basically our starting point for this gear and allowed us to move on to the next part of the sketch, which was the teeth of the gear. So with the teeth of the gear, I went ahead and for the sketch, I first drew another circle that matched the exact same circle, 1.25 inches. This just gave me a basis to start sketching the teeth on. So what I did was I created a center line from here all the way up here, and it's a little bit hidden, but you can see it right there. This center line helped me create these constraints that you can see right here. So what I did was I started drawing from the center line out down to a point here and then back to the center line. And so with this, I was able to mirror this across this to create the image of one teeth. And after I got that set in place, I went ahead and started adding my dimensions in. This entire piece was 0.08. And over here, to lock this into place, this to all the way up here was 0.7 inches, which gave this a height of around 0.11 inch per teeth. And then to have the teeth be at an angle, I went ahead and I clicked these two lines to set a dimension of 110 degrees. And so after I added in those dimensions, and I also added in an extra couple other dimensions to lock in everything, I went ahead and I used the circular sketch pattern. And if you click the circular sketch pattern, you can see all these different things right here. So what I did was I went ahead and my parameters were basically this entire sketch right here. I went ahead and I mirrored it 17 times around. So that was to give 17 gears to give equal spacing, and that also allowed that the distance between these two was also around, give or take 0.08 inches. And so after that, we went ahead and I mirrored sketch using the mirrored sketch pattern all of these teeth, and I went ahead and extruded it the 0.25 inches to fit the entire circle. So after that, that's probably the hardest part. I went ahead and I shelled the inside of that just so we can use less. This is also an additional optional step. This is just to reduce some of the 3D printing costs. And the shell here was, I believe, around 0.05 inches, just so that we can reduce some of the weight while we're printing. Finally, we added this little lip right here. This is just to give increased surface area to attach onto the handle to rod connector. This was a fairly simple build. What we did was I sketched on this plane right here, this front plane right here, and I sketched two circles. I had the inner circle already sketched, and then I added another circle as 0.93 diameter, and I set a definition between this line and this line that it was 0.05 inches. That fully defined it, and then I was able to extrude just this part. Go ahead and take a look here. I was able to extrude just this out a little bit, 0.1 inches. And afterwards, I did the same exact thing on the back. If I had to redo this, I would probably just mirror it across the front plane and use the mid-plane extrusion, but I just had to do it twice. And another part I forgot to mention earlier was the hole here that was created through. This was very simple. It was basically we sketched out 0.93 on the boss extrude 1 face right here. It was a circle with diameter 0.93 from this using the midpoint of the overall first circle. We would then use a cut extrude to just cut the entire thing all the way through just so that we had a clear hole. And so there we go. That is our inner gear. This is complete and it's fairly straightforward to do. Moving on to the second part of our gear mechanism, this is the top gear that the user actually controls to move the device in its 360-degree motion. It is very similar to the inner gear, but in the way it's designed. However, it does have a couple of tweaks that make it a little bit different. Moving on to this history tree over here, we'll go ahead and look at the first sketch. Again, we start off with a circle, but this time a lot smaller in 0.75 inch diameter. This allows it to fit within the handle, as due to its constraints, we had to make this size a little bit smaller than the other gear. Furthermore, we went ahead and we just extruded it out 0.25 inches as well. And moving on to the gears again, the gears were also the same process as before, where we used a circular sketch pattern to this time do only 9 instances. The teeth are all the same size as before, just so that it can fit snugly and there wouldn't be any interference between the two gears. Again, it's only 9 instances because of the size restriction that we had with this top dial here. We then extruded it out again 0.25 so it could cover the entire width of the gear itself, and moved on to the next part. So this part right here is where we went ahead to extrude out these little rod pieces right here. This is so that it could rotate by itself freely. If we can see here, we had a sketch of 0.30 diameter, and we went ahead and just extruded that piece out past the gear a little bit, just so we can have some room to be able to put this on its own axle and rotate. And we can see here that it was extruded about 0.625 inches. On the other hand, we went ahead and extruded it out the same way this way, but this time it was only extruded out 0.375 inches, so the total length of this was exactly 1 inch in length. Finally, we added these cuffs right here just so that we can have some protection from the gear rubbing against the side of the balls, and also to prevent this from sliding left to right when rotating. Now this was also designed in the same way as before, where we basically took a slightly larger circle, in this case 0.40, and we went ahead and we just extruded this out of this line right here using the 0.3 circle before. We extruded that out around 0.12 inches to get that little lip right there, and did that also for the other side. And that is how the top gear was created. And yeah, it was very similar to the inner gear, and both of these work in conjunction with each other to be able to move our device in a 360-degree manner, and are both key aspects in the overall suturing device. Thank you for watching, and have a great day.